All right, ladies and gentlemen, this is our last unit for this chapter. So we're going to finish up. This should be a fairly short video. This is some of the kind of exception to some of the reactions that we've talked about so far, and in some cases, just something really cool. So the first thing we're going to talk about is this. DIBAL. That's what the name of this is. Now, what DIBAL is, it is a variation on lithium aluminum hydride. In fact, it is specifically this, where these right here are called isobutyl groups. So DIBAL, I probably should have said this at the beginning, stands for di-isobutyl aluminum hydride. What DIBAL does is it takes the hydride reducing agent and it kind of ties two of its hands behind its back. So it is a limited reaction for a metal hydride. Specifically, let's take a look at lithium aluminum hydride. All right, there are 4 sites for reaction on lithium aluminum hydride, and all of those hydrogens have a very strong partial negative charge. On DIBAL, I'm just going to put these as R because I don't have a lot of room there. You've got one hydride with a strong partial negative charge. You've just got one of them. So what are some of the cool things that DIBAL can do? Well, let's take a look at this one. We're going to take an acid chloride and we're going to react it with DIBAL followed by water. Now there's a key to the DIBAL reagent. It needs to be kept pretty cold, specifically minus 78 degrees C. And what you get out of this is an aldehyde. You get an aldehyde out of this reaction. Now that's pretty cool because if you think about it with what we've done before, you would react the acid chloride with lithium aluminum hydride and water, you would get the primary alcohol. Here we can add the hydrogen and stay there. And I just messed that all up, so let's try it again. And it will stay there. Now, does this work with things other than acid chlorides? Absolutely. You can react esters. All right, you can react DIBAL with an ester. Again, it's got to be kept cold, and what we get out of it is the aldehyde. The same thing happens if you react an acid with DIBAL. Now, you're probably asking yourselves, do I have to include that negative 78 degrees C every time I do this reaction? And the answer to that is yes, you do. It's one of the few areas where I get super picky. So let's take a look at another set with this. Let's look at this DIBAL reaction with an amide. DIBAL followed by water at negative 78 degrees C, and what we get out of it is an aldehyde. Just like the other ones. Awesome, right? Well, here's why we got to worry about the temperature. If you take DIBAL and you react it with that amide, but you don't have it at negative 78 degrees C. Instead, you've got this at 0 degrees C. A sauna compared to where we were. Now all we get is the amine. I'm not bothering you with mechanisms for any of these because honestly, I don't think it's that crucial. I don't think, honestly, you know what the mechanism should look like. And at this point, I'm just showing you these because they provide you with some very nice synthetic tricks. Finally, for the DIBAL section, let's look at what happens not when you have an acid derivative, but when you're playing directly with a nitrile. So DIBAL at minus 78 degrees, followed by treatment with water. And what you get is, you guessed it, ladies and gentlemen, the aldehyde. DIBAL is the aldehyde making machine. So that ends with DIBAL. There's one more reagent I want to show you, and it's called a Gilman reagent. A Gilman reagent is an organocuprate, meaning we're bringing copper into play. A Gilman reagent looks like this. You have the two carbon groups attached to a copper, which is negatively charged and is counteracted by a lithium. Like the DIBAL, Gilman reagents only work best when you're at minus 78 degrees C. If you're above negative 78 and you get up to, say, zero to room temperature, what happens is these act like organolithiums. It's at this negative 78 degrees where we get magic. Now, we're going to look at several different types of Gilman reagents as we go merrily on through these chapters. The one reaction I want to show you now deals with an acid chloride plus one. Let's say we've got this. Now, let's take a look at that Gilman reagent I have up here at the top after I write in the negative 78 degrees C. Let's take a look at this Gilman reagent right here. The structure for this would look like the following. Okay? That would be the structure of this. Now, here's your product. You ready for this? As long as you keep it cold, you can turn the acid chloride to a ketone and stop. No further reaction would occur. Like the DIBAL, this only happens when you keep this stuff cold. All right. Why did I make such a big production out of showing you these? Both the DIBAL and the Gilman reagents are nice tricks to have up your sleeve for when you start thinking about different synthetic methods, because like I've said, all of Organic 2 is getting you to be able to do multi-step synthesis. So I'm going to end here. Everyone have a great holiday weekend. I will be back on Monday with some more videos. So take care of yourselves and be good.